Welcome back. You see in our mind map here that we're now in the sorting section. And this big O of n log n, something we haven't talked about, is showing up. We'll get to that in this section. But I want to add a quick note here. Looking at all these sorting algorithms, and there's a lot more. It's important to note that you don't need to write a sorting algorithm from scratch, most likely ever in your career. Frameworks usually do that for us. But you do, however, need to know how they work because, well, one, you're most likely going to get asked in an interview, and two, because it makes you a better engineer. But this section is also about being efficient. You see, you can spend a lot of time on each one of these sections implementing your own and talking about it deeply. Because I don't think I've ever heard of anybody actually having to implement in code manually these sorting algorithms. Most of the time, you can just talk about it, or the interviewer tells you that the array is sorted and you need to know what to do with it. But implementing it from scratch, that doesn't really happen. But I've included it in this section because it's good to know how they work. And I'm not going to lie, coding sorting algorithms is not my favorite either. Don't let that deter you. I encourage you to watch the next couple of videos and even practice coding your own sorting algorithms because it will help your learning. But the main thing that we're going to get from this section is not how to implement these. I mean, we will do that, but the key is the trade-off. You see, we have the big O cheat sheet here that we definitely know about, right? We talked about data structures and how there's trade-offs. Well, when it comes to sorting, there's trade-offs as well. You see how there's some time complexity trade-offs, space complexity trade-offs. And it's important to know when to use what algorithm. That's our goal of this section. And before we get into our first sorting algorithm, I want to show you this nifty little tool that I'm going to link to. We have a few sorting algorithms. We have insertion sort, selection sort, bubble sort, shell, merge, heap, and then 2 different variations of quick sort. And we also have different data sets. This is a random data set. See how they perform when I click here based on different sorting algorithm. See that they're all working and all of them finish at different times. One is a lot slower than the other. What about nearly sorted? Again, one, such as insertion sort, is really, really fast, while others are slower. Reversed, if the items are reversed and we need to sort a completely reversed list, again, different algorithms perform differently. It's never one that wins out over the other. Depending on the inputs, what we need to do, they're different abilities. Let's start to learn about these different types of sorting algorithms so that by the end of these videos, we can make the right decision when to use what. I'll see you in the next one. Bye-bye.